Hello friends, this is Praveen and today we are going to learn about the square and square roots. So we have seen about the addition many times, which we all known as the multiplication, and the multiplication many times it is known as the exponents. So in which that is subtracting many times we get as a division, and the subtracting many times that is dividing many times we got a negative exponents. So but if I have to do not for a many times, but I have 2-3 terms such as a point. We know that a point has a 0 dimension, so we cannot include it. So we know if I have a line and this we have it is one dimension, so we got it as 1D. And if I make this length and extend it up to its breadth, so I get up a square. So this is a square, and but if I stack many squares together, we know that a solid figure, that is a cube, is formed. A cube is formed. So we take initially a small point and go through a cube. So in our math, same as the first, we obtain a single line that we know as numbers, and then we multiply it, we get a square, and then to the square we get a cube. So this we have only learned in geometry. Can it be happen with numbers? Yes, this can be happen with numbers. So first let's learn about the square numbers. So a square number can be defined as a multiplication of the number 2 times. So if I have this line and I multiply with its breadth, so I get this line, this square. So we can take the square as the multiplication of the something 2 times. So now let's learn about the number patterns. How we can obtain the square with the help of a number pattern. So we know that the simplest number pattern would be a number line, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on. So now if I take the sum of the first number, that is 1, and then take the sum, that is 1 is equals to 1, in this second if I take, that is 1 plus 2, which I get 3. 3, then we get first 1 plus 2 plus 3, we get, that is 6, and then we get 1 plus 2 plus 3 plus 4, we get 10. Then 1 plus 2 plus 3 plus 4 plus 5, I get 50. So what are these numbers? Such as 1, 3, 6, 10, 15. So what are these numbers? If you would arrange these in the form of a dots, so if in the case of first dot I have one dot only, this in the second case I have 1 and 1, 2. In the third I have 1, 1, 2, 1, 2, 3. So if I join all these dots, in the first case it would be not possible because only one dot is possible. In the second case, if I join these dots, so I got upper, and in another case 1, 2, 1, 2, 3, 1, 2, 3, 4. In this case also I am getting a triangles are formed. So these numbers are known as a triangular numbers, because as you can see they form the triangles. So the number 1, 3, 6, 10 and 15 are known as the triangular numbers. So now we have add these numbers. Now can we add these numbers and find a pattern? Yes. So if I add these two numbers, I get first I am adding 1, so we have 1, then 1 plus 3, then I have is 4, we are adding these two, then 1 plus 3 plus this we get, that is 9, this 3 and 9, and then we add 6 and 10, we get 16, and then we get add 16, that is 10 and 15, I got 25. So what are these numbers? So let's again visualize these numbers as a form of the dot pattern. So I have one dot, and now I am adding simply adding 3 more dots. So that means 1, 2, 3. So I can see it was my inertial dot, and therefore this was a triangle and this was a triangle. So we know that we can form a square by adding 2 triangles. So in the same way, it forms a square. Let's take this number, that is 3 to the 6. So I have 1, 2, 3. Then I can add is 1, 2, 3, 4, 5. That is 6. So I have again get a square. In the same way, if I do with this number, then I will got 1, 2, 3, 4, 5, 6. And I do with 10 more dot 1, 2. I got a square. That is simply nothing but simply for the number which if you have is n here, the n number of times the more dot is repeated. So these are known as a square numbers. So now we have visualized these as a form of a square number. So now let's move to the squares. As we see, what is a square? A square is nothing but the multiplication 2 times. As we have seen in the scenario of the diagrams of dot and as well as the number patterns. So if I have a length of 2 and I exceed or add up this length by 2 times. So I got up to 4, but it is not 4. What 4? This if it is 2 centimeter and if it is 2 centimeter. This can't be 2 centimeter because 4 centimeter will be only in the one dimension. So we in the exponents we know that we write the terms how much we are getting multiplied as a top, which is known as exponent. If I have the number e, which is our number, and it is multiplied by p times. So here p is our that is exponent or a base, or it is known as an index or power. So we know that if we have this, so we can write it as 2 square plus centimeter, because centimeter is also multiplied with centimeter, so we can write it as centimeter square. So if anything is given, the area is defined as the square of that unit. So now perfect squares. What are perfect squares? Perfect squares are the numbers, the natural numbers when multiplied 2 times. So if we take a scenario that is 1 multiplied by 1 is 1. So it is a perfect square. But if you will multiply, that is 0 multiplied by 0, which that is 0, it is not a natural number. So answer would be 0, and 0 is not a perfect square. So let's how much we can go. So first, if I have 1 multiplied by 1, that would be nothing but 1 square, and that is 1 multiplied by 1, we know 1. If I have 2 multiplied by 2, we got as a 2 square, that is 4. Let's do, that is 3 multiplied by 3, that is equals to 3 square, that is equals to 9. If we do 4 multiplied by 4, that is 4 square, that is equals to 16. Then we do 5 times the 5, that is 5 square, that is 25. Then we do 6 multiplied by 6, that is 6 square, and that is 36. 7 square, that is 7 multiplied by 7, that is equals to 49. In 8, that is 8 multiplied by 8, that is 8 square, which is equals to 64. And if we will do consider it as 9, it would be 81, and 10 it would be 100, and then for 11 it would be 121, and so on. So these are the examples of the perfect square. So you can see that the number between 1 and 4, which are 2 and 3, are not a perfect square because we are multiplying 1 by 1 and 2 by 2 to get these numbers respectively, and there is no natural number between them. That means neither 2 or not 3, and you can take the here also there, which is 5, 7, 8, which are also not. And here if you will take, that is 10, 11, 12, 13 and 14, as well as 15. These are also not the perfect squares because they are lying between the two. If you multiply the two nearest numbers, we cannot obtain these numbers. So now let's move to the properties of the natural number, that is natural numbers when multiplied by the same number. So first we have is ending numbers. If you will see, in this scenario, we can see that all the numbers, if you will take the square of 1, it ends with 1, then 4, then 3 it ends with 9, then it's 6, and then 5, and then 6. We know that 6 is again repeating, and then it is again with 9, and then it is 4 and 4, then is 1 and 1, then 0. But if you will take the square of 121, that means it is also ending with 1. So if a square has to be perfect to square, it must end with which numbers? It could be either 0, 1. In this case, we have not a 2, so here is a perfect square, and here is non, that is perfect square. So 2 is not here, so 2 would, if a number is ending with a 2, it is not a perfect square. And if we as a similarly we cannot say 3 in that, so 3 is also ending factor of the non-perfect square numbers. In the same way, 4 we can see here, so 4 is here, and as well as 5 is also present here, 6 also, but neither 7 or nor 8 is present here, but 9 is present here. So we can conclude that all the perfect squares ends with 0, 1, 4, 5, 7, that is 6 and 9. If they are not a perfect square, then they must end with 2, 3, that is 7 and 8. Here you can see that a 35 ends with 5, so it must be a perfect square. In this case, I have not told you that a number ending with this number will be a perfect square. I have told you that if a number is ending with these numbers, then it could be a perfect square. If in the options you are given these numbers which are ending with these numbers, so then you have to find out the squares of that number and check if these numbers, so these we can cut it simply because they are not the perfect squares ending number. So now let's move to the division. So one more interesting pattern you can see, that is when a number is being divided. So here we have two factors, which is 3 and 4. If you will divide any factor with 3 and the resultant, if we have the n, which is a number, and n same here, which is divided by both these, if they have the I just like we have a quotient q in the both the scenarios, but in this case, if the number has a remainder, that means it is remainder is in the case of 3 is either 2. If it is 2, then this number is not a perfect square. And the same way, if in the when we have the divisor 4, and if it is ending with 2, or you can take 3, then this is also not a perfect square. You can directly eliminate, because these are the not perfect squares. You can try with any of these scenarios. Let's take 3. If you will divide by 3, that is 4. 4 divided by 3, we get the remainder of 1. So the 4 is a perfect square. But if you divide the 5 by 3, we get a remainder of 2. So it is not. In the same way, if you are dividing by 6, the 6 is completely divisible, so hence not. 6. So okay, now let's move to the odd and even number. So interesting pattern is followed, that now if you will multiply the two odd numbers, we get the square is also odd. So here in the same we have is a odd number, and the square here is also odd. But in the case of 2, if a number is even, the square of this number is also even. So it also follows with all the perfect squares, that is 3, 4, 5, 6, 7, 8, 9 and 10. And this principle also works with the non-natural numbers. If you will multiply with 1.25, then you can be guaranteed sure that this number will be end with a odd number. And if we have is 1.20 multiplied by 1.20, then this number would have a even number at its unit place. So we can conclude that a square of the odd number is always odd and the square of the even number is always even. So we can see now I have told you the number must be odd, but which number would be that there? So this we can take out by we know that if a number is ending just like in 1.25, the number is ending with 5, and here we can predict that because here we have also 5 and the square is ending with 5, so the unit place will be 5, but in the 2, if we have is a 2 in the case 1.2, here after decimal point if you put a 0 that doesn't mention, so 1.2 multiplied by 1, that is 1.2, we can see that it would be 4 ending with 4 because the unit place is a squaring, we will get this unit. In the same way, if we have is a 4, so that is we have 2.4 multiplied by 2.4. So here 4 times 4 which we get is 16, but we know that the unit place can be only one, which is the 6 is the unit place of these numbers. So in this odd numbers, there are the squares of the odd numbers are odd and the squares of the even numbers are even, and we have seen if a number is ending with 1, it would unit place would be 1. If it is 2, then the unit place would be 4, then 3 is to 9, 4 is to 6, that is 6, 5 is to 5, then 6 is to 6, 7 is to 9, then 8 is to 4, 9 is to 1, and then 0 is to 0. Okay. So how could I, if there is we have given a is 1000 a perfect square? We can take this because if you will multiply any number ending with 0, so let's try it with, so if I have first 10 multiplied by 10, I got 100. If I let's check for 100 multiplied by 100, I got 1 followed by 4 zeros, that is 10,000. So a pattern goes on just like it has all the even numbers of zeros, because we know that when to simply multiply we have to put these zeros at the back. So plus and plus, we know that when the two numbers are getting added 2 times, that means a odd number is added with odd, the number would be even. And when an even number is added with an even, we get the answer as again as an even. So the numbers of the zeros of the perfect square at the ending must be the even number. If it is odd, then it is not a perfect square. So now let's move to the n plus 1, the square minus n by 2. N raised to the power of 2. So if I write this n plus 1 square and we have minus. So if we have this, so how we can solve this? We can take this expression also written as, that is n plus 1 plus n multiplied by n plus 1, and then we can take this as a n minus n. We can write this as, so this could be as simplificatedly write as n plus 1 plus n. So we can directly put it as the, that is n plus 1 plus n. So this would be our simplification of this answer. So now let's move to the first and odd numbers. So if you will take, let's take, we have taken all the in the numbers pattern, we have taken all the numbers. Now let's take a scenario with all the natural, that is natural odd numbers. So first if I add 1, then the add is on the next odd number, that is 5 plus 7. So we can see the answer is 9. So we know that we are adding three numbers and this answer is the 3 square. So is this number or two? Let's check one more time. That is 1 plus 3, that is 4. It is adding two numbers and it is the square of 2. Let's see, 1 plus 3 plus 5 plus 7, that is 16, and that is 16 is the 4th square. So this is not a coincidence, but if we take the first n odd numbers, so and the answer we get would be the nothing but the nth square. So if I am using first three that is odd numbers, the answer would be n square, the sum, and if I am taking the first and 2 here, the first 2, then we our answer is n the 2, that means 2 square, that is 4. So this is the adding of the first odd numbers. So now let's move to the Pythagorean triplet. So we know that if I take a right angle triangle, that means here if I consider with A and this considered as with B, so this would be the C. That if you are taking the C, then it would be nothing but that A square plus B square whole under root. So which numbers follows this pattern? If I take it this number as 3 and this number as 4. So 4 square, that is, we know that 16, and 9 square, that is 9. So answer we get is 25. So 25 under root, we get this value as 5. So if we are getting this square triangle in which all these numbers are that is natural numbers, then these numbers are called as the Pythagorean triplets. So how can you find whether the number is Pythagorean triplet or not? Or if they have told you that is one number is 3, then find the two rest numbers. So we could find this as we have a formula, that is we take 2m, which is the first Pythagorean triplet, and then we have is m square minus 1, which will be the second Pythagorean triplet, and then we have is m square, then we have is minus that now we are adding 1 to it. So these are the three Pythagorean triplets. If we will put the value of m as 3, we get as 6. Now that is 3 square minus 1, that would be 8, and now we are taking 8 plus that is 9 plus 1, that is 10. So we can directly consider that it will be 36 and that this will be 64. Then we get his answer as 100, and 100 under root, which is 10. So we know that 10. So this is the method to find out the Pythagorean triplet. You can solve these questions if only one number is given and we have to find another. Directly use this formula. So now let's move to the consecutive squares. So let's take consecutive squares in which if you have is n, and the next that will take n square, and the next number would be n plus 1 whole, this whole power of the square. So these two are the perfect squares. I can consider it as an example. If I am taking the 4, then it would be that is 16, and 5 square, that is 25. So if it is n, so if I double this n, that is 2 times 8, is this also a perfect square? No. We can, all the numbers between the two perfect that is consecutive to perfect numbers are not the perfect square. In this scenario we have seen that number 2 and the 3 are not perfect squares, and where in the same with 5, 7, 8, as well as 10, 11, 12, 13, 14 and 15, and it goes so on. So now let's move to the squaring numbers. These are the small numbers. We know that if you will how we can get 9, because multiply by the 2 3 times. So the 3 2 times. But what is the large number we have to find out? So if we have the like 72 multiplied by 72. So what you will do, simply first you have to multiply it, that is 2 times 4, 4 times that is 14, as well as now we have to 14, 1 carry 49 and 50, we add this up, that is 4, 8, 1, 1. So this has consumed a lot of time and this number is not really large. So what happens if a really large number is present? How we can find out the square of it? So we have the two formulas. So first let's move to this column formula in which we have to create a three column, and here we have to write as a square, then we have 2 times a, that is 2 times a times b, that is 9, and then we have is write as b square. So if we have this 79 present, 72 present here, so what we have to do? Let's put the a's value as the 2 and b's value as that is 2 and a's value is 7. So we know that 2 square would be 4 and a's square would be 49. We can get this. And now we have to multiply that is 7 times 2, that is 14, 14 times 2, that is 14 times 36. So here we have to consider this number, so it will be standing at the same position. If another number is present, only we have to keep a unit place in there. And here only we have to keep a unit place which we already have here. So we get this as, we have to plus this 50, we get this 50, and now we can write it 50. So this is the square of 72. Simple. So with this formula, you can calculate all the squares of the two-digit number very easily instead of multiplying them. So what happens if there are more than two digits number? So you have to make this a square. If you have, let's take again the example of 72, and now divide these squares with a diagonal as shown. So if I have to digits, I have to make the square by 2 by 2. So here I could write 7 and 2, and here I could write 7 and 2. So if it is more numbers, you have to make the more squares. So what we have to do is write the multiplicative of these first numbers in the first column. So I have 7 times 7, that is 49. So I can write it as like that. Means these two numbers are in that. But what happens if I multiply here, which is 2 and 2, which would be in this column? It's only 4 digit. How do I write? We can write that is 4 as 0, 4. It doesn't change, so we can write here is as 4. And now 2 times that is 14, and now we can write as 14. So you have to take this first column as it is. So we have this 4. Now we have is 8. In this column we have is 1 plus, that is 11, and 1 carry, that is 5. So we have this square. We have to separate. This is nothing, we have take out the squares. But what happens if they are not telling about the squares? If one number is given, you have to find out by multiplying which number you get that number. So we have now about the square roots. So method could be 4. If you are taking an example of 144, this method is known as the prime factorization, in which you have to divide the number by the prime number. So this number is divisible by 2, and then it would give us 50. 50 plus 22, that is 72. Then we have 2, then is 36. Then again it will be divisible by 2. So we have 15, 18, 18 divided by 2, that is 19. That is 3 times 3 and 9. So now we have divided these numbers. Now we have to make the pairs of 2. And we have to make the pairs of 2 because the square is nothing but multiplying the 2 numbers. So I get is 2 multiplied by 2 multiplied by 3. We are taking each number from a group only once. So this answer is, that is 2 multiplied by 2, 4, 4 times 3, that is 12. So this is the square of 12. This method also helps you to find the questions like what smallest number should be multiplied to get the perfect square. So if only one freeze would be presented here, so it would be one more 3 should be multiplied to make it a perfect square. That would be nothing but multiplying the 3 we get that number. The another method to square root is the division. Let's take example of the division method. In this, let's take the example 5, that is 758. So first we have to assume the smallest number by which this is divisible. So we know that here the 2 is the smallest number we can divide with it. So 2. So here we have to write down the smallest square number or the equal which is 2 from which 7 is divisible. So we get is 4, which is 2 is square 2 multiplied by 2 we get 4. So we have to answer is 3. And now we have to take this 4 as a 4, and so we can write as 8. So here I have to multiply by 548. So here 548 minus I got answer as 0 0, and this is 8 times. So we get answer as 8. So the square is 20. Square root is 28. So what happens if a non-whole number is given? So if let's take a scenario of points, that is 1.44 is given. We have to find out the square root of that. What you can simply do is take this number out, and we got this 2 zeros here present. So which is, now we have to square, that is square root it. That means 144 square root, that is 100 square root. So that would be 12, and 12 divided by 10. So we can take as a square as 2.5. That is 1.2. So this would be answered if first we have to convert into the fraction which is by the power, which is also a perfect square. So friends, let's summarize what we have learned today. First, we learned about the introduction to the square numbers, and we learned about the square numbers with the geometry and the number patterns. Then we learned about what exactly is a square, perfect squares, then the properties of the perfect squares, which are ending numbers, division, even or odd numbers, that is n. Then we have is n plus 1 the square minus n square. Then we learn about the first and odd numbers, Pythagorean triplets, consecutive squares. Then we learn about squaring numbers. Then is square rooting the numbers, where if it is not the whole number and if it is the whole number. So friends, I hope that the square and square root chapter is clear to you, and at last, thanks for watching.